In my research team, one of the questions we ask is how can the power system of the future become more equitable? As we are moving towards electrifying everything, a large consideration for equity and equality is people's access to a reliable supply of electricity. If a person finds themselves in the middle of a disaster, they may go through a blackout and not know how long it will be before the electricity comes back online. This is really important for people who are experiencing medical needs, such as needing oxygen tanks or heart defibrillators, and also for community centers that may take care of large homeless populations. So one thing that we have done is we have been looking at a simulation model to analyze the trade-offs of microgrids and resilience hubs for mitigating electrical outages in households during disasters. And my student Arnav has been building a distribution network model, which can help answer questions like, what are the economic and environmental sustainability trade-offs for deploying microgrids in a region?
My research focus is on decarbonizing the electric grid with equity as a central consideration. My current project looks at power outages as a result of natural disasters and how to best protect vulnerable communities during those situations. Now, cities are developing what they're calling resilience hubs, which are community centers augmented to keep their lights on and provide services during disasters. I am researching what the different backup power options these resilience hubs have. There are different technologies like solar panels, batteries, and hydrogen fuel cells that can be combined in different configurations, each with their own trade-offs. And depending on the size installed and the location on the electric distribution network, the possibility exists for these resilience hubs to not just stay powered on, but actually share electricity with their neighbors during an outage. So the distribution network is the wires and transformers that exist within a city to transport electricity to the different buildings that exist. It's in contrast with the transmission network, which are the long-distance power lines that you may see crossing the country. To study all of this, I've developed a custom simulator of electrical distribution networks, which I can use to run a power flow analysis of these different setups. I then run a multi-criteria decision analysis of my results, which is essentially quantifying the trade-offs between each setup's economics, environmental impact, and social benefits. Policymakers can make use of this electric distribution network simulator and multi-criteria decision analysis framework to evaluate real-world options that they are presented with when looking at a specific resilience hub installation.